go ahead and fill in some of the definitions or ideas around rational functions that we've discovered from this unit or this lesson. So first of all, a rational function in this class is going to be made up of a function that divides two linear functions. So it's the quotient of two linear functions. And again, a linear function has a constant additive rate of change. So I'm going to call this r of x since it's a rational function. That's going to take f of x divided by g of x, where f of x is a linear function, and so ax plus b, and we're going to divide it by another linear function, cx plus d. And so we have one linear function, so linear function number one, and we're going to divide that by linear function number two. And when we do this, we end up with a denominator. And because all rational functions have a denominator, that means that all rational functions will have a vertical asymptote. And this vertical asymptote happens because we cannot divide by zero. So this vertical asymptote happens because division by zero is not possible, or we can't divide by zero. Which makes the function, which will make the function undefined. The other thing to keep in mind, when we have this vertical asymptote, that vertical asymptote divides or breaks up the domain because it's going vertically. It would be like a wall in your house. So that's going vertically, breaking up, say, from one room to another. And so that vertical asymptote is an imaginary line that the domain approaches, or that breaks up the domain, so when we draw this vertical line, we're breaking up left and right, so we're breaking up the domain. And that imaginary line, or that vertical asymptote, is always going to be of the form, since we're breaking up the domain, that means we're drawing it vertically through the x-axis or the input axes. So the equation is going to be for this is x equals some value, where that imaginary line is going to be created. And so We're going to look at a couple of graphs to see how how we're going to graph these to make sure that we understand what this idea of a rational function having a vertical asymptote looks like in terms of a graph.